So friends, in this video we'll look at application of Gauss law, and the first application is again to find net flux using enclosed charge. Okay, so we'll use this definition. Net flux is Q enclosed by epsilon naught. Somehow we'll calculate enclosed charge and we'll get the value of flux. So in the following cases, this is a rod which is passing through a cylinder of height h, radius 2r as shown, and the charge point length is lambda. Okay, so we have to find that what is the amount of flux through the cylinder. Q enclosed is lambda into length enclosed. What is the length enclosed by the cylinder? Is lambda into h square plus 2r ka whole square. So flux is nothing but Q enclosed, which is this 4r square by epsilon naught. Okay, in the second case, there's a again similar kind of rod passes through a sphere of radius r, such that rod passes through at a distance d from it, from the center. So again the length enclosed, let's say we have to find this length. This is L, so this will also be L. So the total length enclosed is 2L. I'll draw the triangle here also. This is this triangle. So this is L, this is D, and this is R. We can easily find L as under root of R square minus D square using Pythagoras, and length enclosed or the charge is nothing but Q into 2L. Length enclosed is 2L, so it will be lambda into 2 times under root of R square minus D square. Flux will be 2 lambda under root of R square minus D square by epsilon naught. Okay, and in this case the rod is placed diagonally. So this is basically the maximum length enclosed. Maximum length enclosed. Okay, you cannot enclose more length than this, which is root 3L or root 3A. A is the side of the cube. So if the enclosed length is this, we can say enclosed charge is root 3A into lambda. Hence the flux will be lambda root 3A by epsilon naught. In the next video, in the next part, there are few charges. Some of them are at corners, some at the edges, and these two are at the faces. So we have to find the net flux through them. Again, for that we will find the enclosed charge. The enclosed charge is nothing but 1/8 of charges at the corner, which is 5 plus 11, plus 1/4 of charge at the edges, 6 and 2, plus half of the charges at the face, 6 plus 2 plus 4, just forget 4, and half of the charge at the face, minus 3 minus 5. So the Q enclosed is nothing but 2, this is 8, 12 plus 3 minus, it will be minus 4, so it will be plus 1, and flux will be 1 by epsilon naught with a plus sign. In the next part, there is a cube formed by planes x equal to plus minus a, y equal to plus minus a, z equal to plus minus a. So obviously the cube is symmetric on x, y, z axis. You can say, let's design the cube first. Okay, so this is the cube. So we can say plus minus a, and here it will be origin at the center. These are the three axes. So what about find the enclosed charge if rod of length a having charge, this is 10 coulomb, is placed at on x-axis a by 4 to 5a by 4. Okay, so length inside is from a by 4 to a, that is 3 by 4 a, or 3/4. Okay, a point charge of 5 coulomb at this and at this. Again, we can say any charge which has coordinates greater than a, any coordinate is greater than a or less than minus a will be outside the cube. So this is outside the cube, a to a, but this is inside the cube. So again, Q enclosed is 3 by 4th of Q of rod plus this 5 coulomb, not this minus 2 coulomb. So 3 by 4th of rod is how much? 10 plus 5, that will give you nothing but it is 2.5, 7.5 plus 5, 12.5. So the flux is 12.5 by epsilon naught. Again, any charge which has a coordinate, any coordinate greater than a or less than minus a, or outside this region plus minus a, so it will be outside. Okay, enjoy.